Hello and welcome back to Quantitative Reasoning Online. Today's lessons will be Lesson 17C Preview Assignment, followed by 17D, and then 18, and that's it. We are almost done. So let's go into the workbook, or the practice area, and let's see. It looks like numbers never lie, and we have 4 questions afterwards. So let's get into 17C. Lesson 17C, Preview. So let's see, looks like we're going to have to recognize features of a graph that may be distorted to mislead, be aware of exclamatory or exaggerated claims. As a result, look critically at any data. And we'll watch a video and identify ways in which statistics can be misleading. Exciting. So in this class, you will see examples of how data can be misinterpreted or misused. Possible responses to the plethora of data in our world are either to trust the data, numbers never lie, or to gloss over the information. It is essential that each person think critically about the data and analyze the conclusion carefully. The tutorial for the preview on Lesson 17C, Part C, Numbers Never Lie, begins here. So let's see, we have a graph here. Cool. The graph in the slideshow represents 3 perspectives on Texan median home prices between 1989 and 2013. A sample headline is given for each graph. So let's see, and of course the source. Graph A, U.S. Census Bureau headline, Texans see only slow growth in household income. Median household income in Texas, 1984 to 2012. Okay. Look at the x-axis, 0 to 60 in 10,000 increments, and the years 80 to 2015, and even 5 number increments. Nothing wonky there. A nice gradual rise. Graph B, U.S. Census Bureau headline, household income for Texas, zoom up. Median household income for 84 to 2012. 80, 85, 90. All right, let's compare 2 graphs. 80 2015, 80 2015, that's the same. Ooh, looky here. Looky. Eliminate this part of the data and stretch this area. Also look at how the compressed the years are. Oops, wrong way. So they looked between 2 graphs, they eliminated dead space here, and of course stretched it out, and they compressed the years. So yeah, it's going to make it look a lot steeper, but it's the exact same data. And let's see, where in the money in Texas see a large jump in household income. And again, the income in 84 and their income in 2012. Let's see, 84 was about 23 and about 52. 23, 52, 23, 52. So it looks like between this graph and that graph, all they did was they eliminated all this data and just had those 2 side by side with each other. Interesting. All right. So what's next? So which graph, A, B, or C, would be the best choice to communicate a summary of the data of the median household income in Texas? Graph A, Graph B, Graph C. What are your opinion? Go on pause for a second and think about it. So which graph, A, B, or C, would be the best choice to communicate a summary of the data of the median household income in Texas? So think about it. So give much thought. A lot depends on what the truth is. This is the most accurate graph. It shows all the data, including 0. B has a little bit of deception in it. I'm not so, I'm looking for this part as missing 0 to 20,000, and that's just incomplete data. So for me, the answer would be A. It's because it shows other data. It shows a increase, and you can also mentally look at it. Hey, between 84 to 2014, it more than doubled. It more than doubled. 23 to 50. And also, really look at this guy here. Really lost. This one really is really bad. This shows roughly a doubling, a little more than doubling, 25-ish to 50-something-ish. This one loses that fact, makes it look like it's an even bigger gain. And really, the next graph was really off this guy. I realize you're missing the 0 here, which would be a much more realistic, accurate depiction of the true change. Yep, graph A. It's the least deceptive graph. In fact, it's not deceptive at all. It has all the information in it. In your notebook, justify your choice in part A by explaining what you think is wrong with the other two choices and what makes your choice better. Again, all the data, do that little bar graph. Shows about a doubling of income. This guy, like I said, I'm not too concerned about this compressing the time scale because it still shows all the time 5-year increments, but it's losing the losing the 0 and 10,000, which again kind of shows, do the bar graph, the doubling, which that does not show. This one, if you're not paying attention to the scale, shows, wow, that's about a 6 to 8 times increase of median wage. Totally deceptive. Bad show. Okay, let's see. You received an email with the subject one weird food that kills high blood pressure from the sender's blood pressure solution. I've gotten that email. The text of the email is shown. The link is not active here. If it were active, would you click on the link? What makes you suspicious about the message? A, I never click on unsolicited health advice. But let's see. Let's just read it. I'm going to go on pause and read it. So what do you think? What about this text message makes you suspicious? Well, for one thing, at best, it's an anecdotal account. Hey, my neighbor says she lost 100 pounds by eating this one food. Okay, where's the scientific evidence? Where's the studies? Where were? Where's the studies? It's anecdotal. No address back. A couple things. All right. Watch the YouTube of Andrew Porter's Lying with Statistics, Misleading Statistics, Fraudulent Advertising at HTTP, yada, yada, yada. Okay, so let's do that. Two-minute video, maybe. Yes. So on your own, you're going to have to watch this limit because, to be honest, I'm not sure if this records or not. So I'm not even going to waste any more time on it. How do I get out of this thing? All right. So let's get back to where we were. So go watch that on your own. It's a rather humorous limerick, and it's pretty good. So part A. You should find watching video. The video describes 4 different ways to lie with statistics, which the following is not one of the methods described in the video. Okay, hopefully you were watching the video and kind of clicking off what you had. If you'd done that, you would have found is in the video he gave examples of basically A, C, D, and E. So the only thing he didn't have in the video was made up statistics. He said you're lying with statistics. He didn't say you made up any statistics. So all the examples were technically statistics, but not good statistics. So the one that he did not advocate was or show was making up statistics. So the answer for part A is B. The video ends by saying that using numbers without context is just lying with statistics. Explain why or how the statement can be true. So think about that one and put it in your notebook and have something that you can think about. Okay, to analyze household income data for Texas in question 1, we now access the Bureau for another state at HTTP whatever. Make a quick sketch or use a spreadsheet to create a graph of the household income data for your chosen state from 84 to 2012. Compare your graph to the Texas graph in question 1. And this is also a link that's broken. Okay. Data needs to fix these things. A link that's broken. And I did find an alternate link, but the data isn't very usable. It's a pain to work with. So let's just realize, I think we've ended up making graphs and using Excel for things. So I'm going to just call this one Smoke 4. I'm going to punt on this one. Okay, so How confident you can recognize features of a graph that may be distorted to mislead? I'm very confident. How confident are you that you can be aware of exclamatory or exaggerated claims, or as a result look critically at any data accompanying these claims? Somewhat confident. How confident you are, you watch a video, identify ways in which statistics can be misleading. Didn't do a whole lot of that, but just realize if they're trying to not giving references, sources, the background to it, the context, it's probably to try to manipulate you. All right, let's see. That is 17C, numbers never lie. And I'll see you shortly for questions 1 through 4.